Assalamualaikum and very good day. So my name is Farzana binti SAAID with my teammates ZAFIRA binti NORDIN and Muhammad Ihsan bin ROS'AZMIR. So this is our video presentation for Lab 8 entitled Digital Filter Design. So in this lab we have two parts. For the first one is we need to open MATLAB software and then enter the FDA tool in command window. Okay, so this is the MATLAB. So once we open the MATLAB software in command window, we just type FDA tool and then click enter button. So once we click the button, the FDA tool will be shown like this here. So this is where is the part that we will proceed for part 4.2, which is okay. So in part 4.2, they already give some question here by some details for the measurement for each filter. Okay, they have 3 different filter here. So for the first one is students need to design the stable low pass butterworth filter. So by entering all the details given here, such as the passband frequency of 1 kilohertz, and then the stop band frequency at 1.4 kilohertz, and then make the attenuation of 1 dB, and then 80 dB for the stop band. So one student enter all the details here, okay, like this, okay. So student can click the design filter here, and then the figure will be shown here. Okay, so the figure will be shown in magnitude response. Okay, so when we want to produce the figure in phase response, we just need to click on the button on top here. Okay, so this is the magnitude response and this is the phase response. So by clicking this button, this icon, it will automatically change the figure into another form. Okay, so for the next one is, okay, we need to design the stable filter. Okay, so to know whether this filter is stable or not, the student need to click on the info menu, info icon. Okay, this is the info icon. So by clicking on this icon, okay, the student will get the some command here. Okay, so this condition for filter is stable. Okay, and then okay, so this is the coefficient for this filter. How to get this coefficient? Student can click on this B, A button. Okay, so once we click on this button, this coefficient will appear here. Okay, so proceed for second question is design a minimum order stable low pass Chebyshev type 1 filter. Okay, so same step with the question 1 just now. Just entering all the value as given in this lab sheet, and then once we click on design filter here, okay, so we will get the figure here for magnitude response, and then change to phase response. This is the figure for phase response in Chebyshev type 1. Okay, and then don't forget to get the discrete time, okay, the info for the low pass Chebyshev type 1 and also the coefficient for this filter. Okay, besides, we also can save this simulation by simply clicking on this button, store filter. So once we click the store filter, there will appear the name for this simulation. Okay, so for example, this simulation will do for question 1, that is low pass Butterworth filter. Okay, as we set here, low pass Butterworth filter. So this name for simulation is automatically renamed on the filter, and then where we can get the simulation. Okay, just click on the filter manager button, and then the file of the simulation we will get here. Okay, so that's all for part 4.2 until question 2. That's all from me. Thank you.
For Part 3, in filter design and analysis tool, we have to assume a sampling rate of 8 kHz to design a low-pass FIR filter using the Blackman windows with a cut-off frequency of 1 kHz. Then we specify the order of the filter such that the first minimum in the stop band, which is preceding the first loop, is as close to 1.4 kHz as possible without exceed it. Besides, from the low-pass FIR filter using the Blackman window, the attenuations was below 80 dB in the stop band as expected of Blackman windows, but the transition band is even more smooth than all. Based on this, we can get the magnitude response in dB and phase response for low-pass FIR filter. Besides, the phase response is linear in the passband and the filter has a constant group delay, meaning that all frequency it can get delayed by the same amount as we can see from the results. It concludes by the comparative value of both magnitude and phase response of the filter using both technique at the same frequency. In Blackman window techniques, the unwanted signals are not present after the cut-off frequency, but this technique also cut the wanted signals. For the result, we can get the filter information for low-pass FIR filter. As a result, we can get the stable low-pass FIR filter and get the 72 numbers of multiplications per input samples. Besides, we can get the filter coefficients for Blackman window techniques. The result obtained using the FIR filter is very complex as the order of the filter required is high. Also, FIR filter have constant group delay while IIR filter do not usually have a constant group delays.
Hello, welcome back to Lab 8 Digital Filter Design. So we go for the lab report questions. First, what is the order of the low pass buttermilk filter you design? So the answer is from this structure, second order section, stable and design. So the answer is this low pass buttermilk filter has 26 order from we can get from the MATLAB. So the second answer is what is the order of the low pass Chebyshev type I filter you design? So from the MATLAB we can get the order 12. So I put the answer this low pass butterworth filter has 12 orders. Last question. Compare the memory usage of each of the three filters assuming a direct form to realization is applied. Do you see how the inefficient the windowing technique is? How much more expensive in terms of memory is the windowing technique from the best IIR filter? IRR filter are the digital filter that have an infinite impulse response. They are also known as recursive filter as they have a feedback. They produce a better frequency response. The IIR filter do not possess linear phase characteristic, this being their limitations. They cannot be preferred for a linear phase system. The IIR filter require less memory and include fewer calculations. That's all from me. Thank you.